Dear students, in the previous class we have discussed the nature of panel data and also the advantages of panel data. In this session, we consider a type of data set having the elements of both the cross-section and the time series dimension, but not panel data first. Then we consider panel data as such. So as I told you in the previous class, data sets having the dimensions of both the cross-section and time series are extensively used nowadays. And such data sets, if available, will give a considerable insight about many policy issues. And we analyze two kinds of data sets having the dimensions of both the time series and cross-sections. That is, two types of data sets having both the cross-section and time series dimensions. One is an independently pooled cross-section. Independently pooled cross-section. Independently pooled cross-section is not panel data. That is, an independently pooled cross-section is obtained by randomly sampling from a population at different time periods. From the population, we randomly select, say, 50 observations this year or this month, another 60 next month or next year, another 100 next year, next month, etc., etc. This is an example of an independently pooled cross-section. As an example, in each year we collect data on hourly wage, education and experience from the population, from the labor force. That is, we want to know, we collect from using a random survey data on hourly wage, education and experience from a large population, or the entire US population consisting of the labor force, etc. And from a statistical point of view, these data sets have an important feature. They consist of independently sampled observations. Independently sampled. In each year, you select number of observations using random sampling techniques. And this is an assumption which is used in the context of cross-section studies. And in the cross-section data, if the data points are collected using random sampling technique, then there will be no correlation between errors across observations. That is, there will be no autocorrelation in space, spatial autocorrelation. Now, but there is one difference between an independently sampled cross-section and a simple cross-section. If you collect a cross-section data in a particular year, say 2015, we assume that the samples or the data is collected and it is identically and independently distributed, IID. If we are using a cross-section data, then sampling from a population at a point in time is identically distributed. IID is an important assumption in the context of sampling. But if you are using independently sampled cross-section, sampled in say 2015, 2016, 2017, etc., we cannot assume that the samples are identically distributed. For example, in the case of wage and education, and if you take 2 years, 2015 and 2019, the distribution of wage and education might have changed between 2015 and 2019. So we can also say that wage and education are identically distributed. But this is not a very serious problem, as we can always take into account we can always take into account the fact that it is independently sampled by giving year dummies to each time period except one. That is the possibility that there will be a difference in the wage and education characteristics in 2015 and 2019, for example, can be considered by giving an year dummy for the year 2019. So this is independently sampled, it is not a panel data. The only thing is we collect data from different time periods, but data collected from different time periods are independent. But in the case of panel data, we assume that the same cross-sectional unit is sampled again and again. If you are taking 50 samples in 2015, the same 50, not 60, the same 50 is sampled in 2016 and 2017, etc. That is the difference. Same unit is sampled again and again. In this case, we cannot assume that the samples are independently distributed. As you are sampling the same unit again and again, we cannot assume that the sample points the observations are independently distributed. The point is the factors affecting wage and education of a person in 2015 will affect the wage and education of the same person in 2019. In the case of independently sampled observations, we cannot assume that they are IID, but we can easily deal with this issue. But in the panel data case, we cannot assume that they are independently sampled. That is the issue. So special tools and techniques are required to deal with the panel data. Before considering panel data, let me explain how we deal with the independently sampled cross-sections. That is pooling independently sampled cross-section. This is not panel data. This is only data collected by random sampling methods from different time periods. As an example, many surveys of individuals, families, firms, etc., repeated at regular intervals, often once in a year. If a random sample is taken at each time period, the pooling resulting in what is known as independently pooled cross-section. It is not the same data points, families, sampled again and again need not be the same families. And if you collect data like this, it will give you what is known as independently pooled cross-section data. One reason for using this independently pooled cross-section data is that it increases the sample size. It increases the sample size. For example, if you have 50 families in 1 year, another 50 in another year, another 100 in another year, etc., etc., the sample size will increase considerably. And when the sample size increases, you will get a more precise estimation and test statistics with more power, etc. Also, using pooled cross-section creates only minor statistical problems. The only thing is, as I told you earlier, we cannot assume that the observations are identically distributed. They are not identically distributed. They will have different distributions in different time periods. And this issue can be easily taken into account by giving dummy variables for each time period. So the issue that the distributions will not be identical in each time period can be easily dealt with by including dummy variables for each year except one. That is the base year or whatever year it is. So what we do in the case of pooled independent cross-section data is, in addition to the variables, we will consider the possibility of a difference in the distribution by introducing year dummy variables. That is, if you have a data point on say hourly wage as a function of education and experience, and if the data is collected for say 2010 to 2015, to take into account the fact that the distribution of observations is different, give dummies for 2011, 12, 13, 14 and 15. And if the year dummies are significant, you can say that the distribution is different for each time period. And sometimes the coefficient of the year dummies itself will be of interest to us. If you read Woolridge, you will see an example given in the book, Women's Fertility Over Time. 2 time periods, 1972 and 84 are taken into account. And a dummy is given for 1984. And if this dummy is significant, we will say that there is a significant difference in the fertility, that is the number of children per woman, keeping constant education and all the other factors constant. That is one example given in the book. Another example is return on education. What happens to the return on education over a period of time and the like. So let me say one more point. Let me repeat. This is not panel data. This is pooling independent cross-sections over time. You collect independent cross-section data with the aim of increasing the sample size. But as the observations are not identical in each time period, you simply consider this by giving dummies in each time. That is the procedure. And sometimes the coefficient of the dummies will be important for you, as in the case of fertility example, as in the case of hourly wage example, etc. That is your choice. And we will not discuss this more, as there is no more theory behind this. And in the next class, we will introduce panel data regression models proper.